Right, okay, emisha video wa araba this question and then we'll play after we finish and then we'll check our solution this one. Right, block A of mass 5 kg, so they're saying block A is having 5 kg mass is attached to block B of unknown mass, which is a mass of M. The string joining the blocks is inelastic and weightless. So what are strings here as a stretch ebile a sena boima jwale re ka affecta boima ba di-block tše dingwe. The string passes over a frictionless pulley as shown in the diagram below. Rather, this pulley here enough friction, rather this string's flow is more than free. An applied force F, so there is an applied force of F with a magnitude of 15 Newton X at an angle of 30 degrees relative to the horizontal plane on block A. So I would say parafilion and 15 newtons is known. So but it's acting at an angle of 30 degrees to the horizontal. Block A accelerates at 2.2 meters per second squared to the right across the rough horizontal surface. So rather the acceleration parafile parake 2.2 meters per second. Right, the coefficient of kinetic friction. Now we have the coefficient of kinetic friction, which is mu k between the surface and the block A is 0.35. So this is our coefficient of kinetic friction. So this is mu k, right? So meaning the friction is only applying on block A. Let's define the term Newton's law in weights and Newton's second law. So we know that around F net equals to MA. So now Newton's law explains the relationship between these three variables. So there's already relationship learning acceleration is directly proportional to F net, and the acceleration is inversely proportional to the mass. So the net force applied on an object, or we can say when a net force applied on an object will accelerate in the direction of the net force with that is directly proportional to the net force, and that acceleration is inversely proportional to the mass. Go and write it using these relationships here. Draw a labeled football diagram of all the forces acting on block A. Here's block A, so we need all the forces acting on block A. So let's show by dot, which is block A. Now the surface. This is the surface. Is horizontal. So now the first force, we have normal force that is perpendicular to this surface. So we're going to have normal force, and then we also have gravity. In this case, that is acting downwards. So we recover Fg that is acting perpendicular on this object A, and then force applied at an angle force applied at an angle. And then the next one, re na le frictional force, and then frictional force is object is accelerating in this way, or acceleration we are feeling you now is accelerating to the right. So friction is opposite the motion, then it will to the left. And then we also have tension. So that's why it's 5 marks. So how many force? 1, 2, 3, 4, 5. Right. Calculate the magnitude of the frictional force experienced by block A. Magnitude of the frictional force. So Robert Gaiwan. Namile razore aranyika frictional force mo ushimisha ura ntoso ndino stress bar file the coefficient of kinetic friction. Ora sonjere ishumisha create the frictional force because friction is drawn from the coefficient of kinetic friction. So ushimisha Fk equals to mu k multiplied by the normal force. So running most of the ring normal force on this object. So let us command normal force pele. So normal force ke yone so ntjudilo e tlhokomela ka ya no challenge. So kamo ar checka the normal force or ke force ile re exactly ke the surface. Then exactly the surface or actually vertically. So act vertical or ronye ka force ka mga di yang vertical, and then it will to show create the normal force. So what re mo ora re na le normal force ya vertical, re na le Fg ya vertical, mara re na le force she ya force applied e le reng e dutse ka an angle theta, which is let's say angle 30 degrees. So I dutse ka mokgwa force a tsamaye vertical or horizontal. So sentse re convert e be le a vertical component and then e be le a horizontal component mo di kopana le di 90. So then all in all ro ba le force tše 3: normal force Fg and the force applied to component which is Fy tše le gore di ya vertical. So sentse re add jona and then re di sign convention. So sign convention re na mo goreng if you bereka this part, so we're going to take up as positive. Then are bona ro ngala normal force one. So re ngala normal force ra reng tše di yang godimo ra di add. So ra ro ba le normal force ya godimo plus Fy ya godimo plus or minus Fg we have so ra minus Fg equals to, now re le kana le bokae mo goreng re checka gore na object ya rena e kgona go move godimo ya fase. So re lebeletse mo the object is only moving acceleration to the right. So ra reng a ye up and down. So ra reng the maatla or force ka tša ya godimo le fase di ba at equilibrium, di a balancana tšene di a re fa 0. Then a di fa 0 mo go ra reng namile o ra swantse re nyaka gore Fy e lekana le, so Fy e lekana le the force applied multiplied by sine of theta. So ra reng e šomiša the opposite over the hypotenuse. So because the F applied is this one and then the opposite is this one, so ra ba šomiša this strict ratio. Namile from there a re bereke mo normal force ra ro ba le reng the normal force equals to, namile ke tšea tše dia ka reng ko ba le Fg be le negative e ba force of gravity ba positive ka mo, then Fy e tlo ba negative. Then if that is the case Oraling re no substitute mo, and then re fa the answer. So oraling Fk, which is force of kinetic friction, equals to mu k into namile are change this one. Re kwana ke mg, I mean ke force applied. Oh, that is mg. Fg is mg minus the force applied multiplied by sine of theta. Namile the kinetic friction equals to, are substitute one, the coefficient like is 0.35. Then the mass of A is 5. 5 multiplied by 9.8 minus this one are 50 multiplied by sine of 30 degrees. Then now Fk, or the Fk, now we'll need to calculate that. Now let's put that in a calculator. Going to say 0.35 then into, then open bracket again, 5 multiplied by 9.8 minus 15 multiplied by sine 30 degrees. Right. So commanded answer of 4,03 newtons. 4,03 newtons. To 2 decimal please. Right, next question. Calculate the mass of block B. The mass of block B. So is with unknown mass. So or kumana the mass of block B. Or sonjor kumane the tension. So our ability on this A renale 3 forces to act horizontal, and then re tseba tše pedi tša tšona, then ye nngwe re tsebe, so re khumana tension. So ra reng sa mathomo ntho re ka idea gore re khumane the formula on block B. So ra re block B is having a free body diagram of this. Is having a tension and F of gravity. Now from this free body diagram, so our formula rena for this block or Newton's second law, running that's what F net equals to MA. Namili F net nale for step exam, so we're gonna ring still taking up as positive. So we're running global tension minus Fy, because Fy here first, then we say minus Fy equals to MA. Oh, this is F gravity, not Y. F of gravity. So this one F gravity cannot langa the mass, but it gets tension, then can win this question. right. Ora sonjero shumisha another block B or create the tension amile arabona in block B. So right in block B ro eta gamma someone who's going to be F applied the cos of theta kabula rumtraving at an angle like this ayilo shoma in the calculations because recognize our even horizontal or vertical field. So sonjero reach this force applied we converted to f component of x, right. Let's erase this one. So in mind we know that the answer here was 4,03 newtons. So instead it's fine. Namile running for block B, block A. This one is for block B. So for block A, for F net equals to MA, namile nalema nale tension moving to the right and then moving to the left is negative, and then renale frictional force moving to the left will never negative friction, then renale force applied moving to the right ever plus the force applied of cos of theta. So require ya apply ka angle I shum so senja reconvert ka cos of theta, so equals to MA, right. Kamo everything renale ona and then raw senja create tension, so roval minus tension, then frictional force we calculate ile yaba minus 4,03 and then plus 15 the cos of 30 degrees equals to the mass of block A is 5 into the acceleration for like 2.2. Mirroring we can have minus t equals to 5 into 2,2 namile tlakameva plus 4,03 minus of this one 15 into cos 30 degrees, then minus t equals to amile press a calculator value 5 2,2 plus 4,003 minus 15 multiplied by cos of 30. So tension Arnold Kumana 2,0 396 newtons. So our sky converter multiply converter on the final answer, we're still going to use this answer. So but therefore tension equals to negative 2,0 396 newtons. So I would say tension are na 2,0396 newtons. So get to be angamu. And then what are guy? Here left to the left. Amil rolling coming to this one. What are we showing tension? Or tension na camera is 2,0396 minus the Fg. The mass is m into 9.8 equals to m into 2,2. So the acceleration system actually a is 2,2, really b is 2,2. So then probalengamo oral to this part right chegamo yaba 2,0396 equals to 2,2 m plus because here it's a positive, so yaba plus 9,8 m. So these are like terms. So what add 2,2 plus 9,8. So about 2,0396 equals to 12 m. So divide both sides m. I'm going to say 2,0396 divided by 12. So the mass is 0,17 kilograms. That is the mass of the block A.